Now let's move to some revision questions in kinematics. We're talking about physics class here. So if you're going to write the upcoming JAMB, so please pay close attention to this class here, because most of the questions we're going to do in this class here, you likely see them in your upcoming JAMB examination. If you are new here, my name is Ken Chris, and I put this video on maths, chemistry, and physics. Now for JAMB, WAEC, and also what higher institution students. So if that interests you, please kindly subscribe to this channel so that whenever I upload a new set of videos here, you'll be notified that a new video will be uploaded. Just also what comments at the comment section if this video is helpful or not, right? So let's look at what the first question. We're going to answer set of questions. We're going to solve set of questions to what explain the various part of kinematics. So we're going to stick to the end of this video. Now the first question you're seeing here is under what velocity time graph, under what kinematics. So let's look at the question here. A car starts from rest. And accelerate uniformly to 20 seconds. Accelerate for 20 seconds to attain a speed of 25 meters per second. Right there. Now it maintains the speed for 30 seconds. So it maintains the speed for what? 30 seconds, right? Before decelerating uniformly to rest. The total time for this journey is 60 seconds. The total time it takes is 60 seconds. A, sketch velocity time graph for the motion. That is what number one. That is what is A. B, use the graph to determine A, the total distance traveled. B, acceleration of the car. Please pay attention. Let me explain to you. This is called velocity time graph. And in velocity time graph here, you are plotting a graph, right? Velocity against what time? Right there. So this is the time. This is what is the velocity, which is v meter per seconds, right? Now this is the time in what in seconds. Now the question will tell you you are going to draw the diagram here. Now here is 0. So here we have this one, here we have this, here we have this, here we have this. Now look at it again here. Now the total time is going to be what 60 seconds. It's going to be what 60 seconds. That is total time. Going to be what 60 seconds, right? Now the total velocity is what is 25 meters per second. So here we have total velocity here is 25 meters per second. Just that. So you have to understand, you have to know the total time. I have to know the total velocity, right? So let's come back again. See that a car starts from rest. Look at the rest here, right? And accelerate uniformly for 20 seconds. So the first time is what is 20 seconds. So here we have about 20 seconds. Right there. So it's accelerates for rest to 20 seconds, right? To attain a speed of 25 meters per second here. So here we have 20 seconds here, right? And here we have the velocity here, which is this guy here, right? So if you should draw it here, going to be like this. This is that. So this is what my first time here. Do you understand? So let's go again. This is that a car starts from rest and accelerates from to 20 seconds, right? To attain a speed of 25 meters per second square, right? So here we have this one here. So here you draw this one here. Just that. Please pay attention here. It maintains the speed for 30 seconds. It maintains the speed for 30 seconds. Right? From here to here, it maintains the speed for 30 seconds. Remember, we already have 20 seconds here. It now maintains a speed for 30 seconds. So 20 plus 30 is 50. So here we have, let's say it's 30 seconds here. And it maintains the speed. Then the speed does not change. It maintains the speed of 25 meters per second for 30 seconds here, right? So you're not going to put 30 here like what I did here. That would be what 50 seconds. Why? Because from here to here is 20, then from here to here is 30. The total is what is 50. This is that. So here we have this one. Then you draw it down. It's okay. You draw it down like this, right? So you can draw it like this. Draw it like this. This that. Now, please pay attention here. Now, it maintains the speed for 30 seconds before decelerating from to rest. Before decelerating uniform to rest. Then when she come here, then it decelerates to this point here. Do you understand? Now you see that the total journey is 60 seconds. So here we have this one here. Do you understand? So this one is velocity what time graph. So the question will tell you how the shape of the graph will look like. Do you understand? Now in velocity time graph here is my acceleration. Here's what is my acceleration. Now here is what is my deceleration. Deceleration. Do you understand? Now here is the uniform of speed here, right? That is it. You have to pay close attention to this other one here. Now, how do we, if for example I say we'll calculate the acceleration, right? For example, if they say calculate the acceleration, they say calculate the acceleration. But if for example I say calculate the acceleration is going to be this one here. Right there, the acceleration is going to be this. So remember, if you want to calculate the acceleration, what is the acceleration? Acceleration is equal to what? Change in velocity over what? Change in time. This that. So what does it mean here? V minus u about t2 minus what? T1. Now because when we talk about graph here, we have initial velocity, we have what? Final velocity, we have the initial time or final time, right? So in this acceleration here, my initial velocity here, remember I start from rest, right? So my u is equal to what? 0 meter per second, right? So when my final velocity is what is v here. V equals to what? 25 meter per second. Just that. Now when my first time, my t1 which got initial, remember it doesn't start from rest. So the view 0 what seconds, right? Then my t2 is what? From here to here is what? From here to here is 20. So it's going to be 20 what seconds. Just that. So my acceleration for this graph is going to be a equals to v is what? Is 25 minus, here we have what? 0 over, here we have 20 minus what? Minus what? 0. This is that. Hope you understand. So here we now become what? 25 over what? 20. What do you have? Here we have 25 divided by 20. Here we have what? 1.25. So my acceleration here is what? 1.25 meter per second square. Now, but now in some question they will ask to calculate what the acceleration. Just which is this one here. Now, but they say you calculate the acceleration here. They say we should calculate the deceleration. Now let's calculate the deceleration first. How do you calculate deceleration? How do you calculate this? Remember, actually, that here is not is acceleration, here is not deceleration here, right? How do you calculate this deceleration? Acceleration and deceleration, they are the same. Just that as deceleration is decreasing, while acceleration is what is increasing. Deceleration is negative acceleration. Just that is it. So let's look at it very well. Remember, here, this point here, I'm going to see here. Now remember, when you get to this point here, if you look at it here, now before it decelerates to rest, here will not be what? My initial what? Velocity. Here will not go what? My final what? Velocity. This that. This is that. If you look at it very well, if you look at it, it maintains speed for 30 what? For what? 30 what? Seconds here, right? Before decelerating. Now before decelerating, so deceleration starts from here. So here will now be my what? Initial velocity. Now once you get to down, now we go on and final what? Velocity. Hope you understand. So here I go my initial final. So here in the deceleration here, my initial velocity here is 25 meter per second. Why my final velocity when you get that, right? Because from here, because the deceleration start from here. So the initial velocity is this, my final velocity is this. This time before you get to down here. So my final velocity here is v equals to what? 0 meter per what? Seconds, right? Now what's my time? Here we have 60, here we have, so at this time here, you're going to be what? My t1, which is what? Is 50 what? Seconds, right? My t2 is what? Is 60 what? Seconds. Just that. So I still got to use this formula here, but it's going to be deceleration. Because I'm going to be what? Deceleration. So you have a equals to final, which is what? 0 minus 25, right? Over. Here we have what? 50 minus what? 60. Right? So it's going to be what? Which is going to be minus 25 over what? 10. Just that. What will happen? You're going to be what? 25 divided by what? 10. Here we have what? minus 2.5 meter per second. Now, why is it minus? Why is it minus here? Now, why is it minus? As I say, why is it minus here? Because it's decreasing. Just so acceleration is always what decreasing, so that's why there is minus here. Why acceleration? When we calculate acceleration, it was all positive, right? That is it. So now, how do we calculate total distance travel? Let's look at it. So now look at what the total distance here. What is total distance here? Now look at something. Just ask here, what is distance here? What is distance here? What is total distance here? Right? Now the distance is the what? The area of the shape of the graph. Area of the shape of the graph. If you look at this thing here, this can be divided into three parts. Here we have the first part. Here we have A, B, and C. Right? Now A is like this. What A is like this is what is a what right angle what triangle, right? Then B is this part here. B is this part, and C is this part here, right? Now, what is the area of a triangle here? What is the area of a triangle? The area of a triangle here, which is on here, area of a triangle here, the area of a triangle here, area equals what? Half times base times what? Height. Just that height times base times height, which I'm going to explain it. Now, here is what rectangle. What is rectangle here? The area is what? Area here is what? The height times base. Just an height times base. Same here. This one here we have what area, which was half times base times what? Times height. So now yourself, what is base? Now base here is what? Is the time. Right there. Then what is the height? The height is what? Is what? Velocity. Do you understand? So instead, if they should have to calculate the distance, you have to calculate distance here, and this distance here. Just the distance here is the area of what right angle triangle here, which was half base times height, right? Here is the rectangle here, height times base, right? This one here, half base times height, half what base times what height. Just that. So what are you going to do here? So let's look at what the first one. Look at what the first one here, which is going to be. So here we have x1, x2, and s3. So here we have x1, x2, and s3. Please pay close attention here, right? So my x1 going to be what? Half times my base. Now my base, my time here. What the time here between here? It's going to be what? 30 times what's my height? My height is 5. Just on my base, look at something here. I think that my base is what? Is my time, right? My height is what? My height is what? Is my velocity. This that. So when I say half base times height, remember the here is what is a right angle triangle here. Half base times height. So my height here, my base here is 30. Then my height here, which is what? Velocity, which is what? 25, right? So if you look at it very well, 30 times what? 25 divided by what? 2. Here we have what? So my x1 is what? Is 375 what? Meter. Just that meter. Because they say is what is distance. Just that. Hope you are following here. So let's look at what s2. My s2 is what? Is what? Height base times height, which called base times what? Height, right? So my base from here to here, what is distance here? 50 minus 20 is what? Is 20. 50 minus 30 is what? Is 20. Because from here to here, from here is 30, here, for here is what? 50 here. So if you share the distance here, 50, 30, it's going to be what? 20 times my height. If you look at my height, here we have what? 20 what? 5. Right? So it's going to be 20 times 25. Here we have 500. S2 equals what? 500 what? Meter. Do you see that? So here we have it from here. So look at what? The S3. My S3 system here, half times base. My base here we have for 50 to 60 is 10, right? 10 times My height here is what is 25. Here we have what 20 what 5. This is that. So here we have what 10 10 10 times 25 divided by 2. Here we have what 1 2 what 5 meter, right? So total distance distance equals to what x1 plus what x2 plus what x3. Just that. My x1, what is my x1? My x1 is what 375 plus my x2 is what 500 plus my x2 is what is 125. This is that. So what you want to do here is what 375 plus 500 plus 125. Here we have what 1000 watts meter. This is not the answer here. The answer is 1000 watts meter. Now let's move toward the next set of questions. Question 2, question 3, and what question 4. So please pay close attention here. So it says that a body accelerates uniformly from rest at 2 meters per second square. Calculate its velocity when it travels a distance of 9 meters. So how do you solve this question here? A body accelerates from rest. Now whenever you are solving a question, you say that a body accelerates from rest. Like you know that the initial velocity is what is 0 meter per second. So here we have 0 initial velocity here, which is 0 meter per second. As well as they stated as what the body accelerates from rest, right? So the body accelerates from rest so the acceleration here is what 2 meter per second square, right? Calculate the velocity. Then the final what velocity, right? When the distance s is what is 9 meter. Now remember we have 3 main equations of motion, which I'm going to give to you here, right? Here we have the first one is what is v equals to u plus ac, right? That is what the first one. That is final velocity equals to what initial velocity plus what acceleration times what time taken, right? So this is what the first one. The second one is what is x equals to what ut plus half at square, right? S equals to ut plus half at square. Now that is the distance traveled equals to what the initial velocity times time plus half at square. Now look at something here. All these are bit derived. Just they did your formula, they derive them, but I'm not deriving them. You have to what know them. Remember, you go to ask you of the derivation in your exam. The last one is what v square equals to u square plus 2ax. So these are what the 3 main equations of motion. Every other equations are being derived from what these 3 here, right? So depending on the parameters given to you, that is when you know the type of question, that is when you know the equation to use. Now, here they ask us to calculate the final what velocity here. Now there's no way we can use this one here. Why? There's no way we can use this one here because now they didn't talk about the time. Just they talk about the time. So this one is at. This is that. Now here there's no initial velocity here. So this one is at. Now the one you can easily use is go to this guy here. Just why? Because we are asked to calculate what the final velocity here. Our initial velocity is 0 because it accelerates from rest, right? Here we have acceleration and here we have what distance. So I'm using this one here. So it's going to be v square equals to what u. What's my u? 0 square plus 2 times my a is what is 2 times my s is what is 9. Just that. So we're going to be v square equals to what 2 times 9. 4 times 9 is 36. Here we have what 36, right? Take the square root of 36 here. This implies that what v equals to square root of 36, which is what 6 meter per second. The unit of what velocity is what 6 meter per second here. So we are doing this other way here, right? Can see how easy it is, right? Let's try this one here. An orange drop to the ground from the top of a tree 45 meters. How long does it take to reach the ground? Now look at something here. This one is, let me write some out here. Now this one you are seeing here, is what is vertical motion. And vertical motion is what is motion that acts with the influence of what acceleration due to gravity. Do you understand? So either a body is what is moving up or is what is coming down. Hope you understand. So when a body is falling from an height, it's called free fall. Now, but when the body is thrown up, it's called is acting against what gravity. Do you understand? Now, if you check it very well, they say that an orange drop to the ground from the top of a tree. Now, whenever look at something here, whenever an object is falling from a height to the ground, it's called free fall, right? And you are still going to use this thing here. The only thing I want to change here is that the A will change to what to G. So here we have what G, here we have what G, and here we have what G. Do you understand? Now, whenever a body falls from a height, we are still going to use these equations of motion here, right? But the only thing I want to do here is that the G, that A will change to what to G. Do you understand? So depending on the values given to me, let me write the whole of this place here. Depending on the value given to me, that is when I will know the formula to what to use. So now let's look at this stuff very well. That's an orange drop to the ground from the top of a tree. So the top of a tree, that is the height, right? You're talking about what height, the height. Another thing I want to show you is that whenever you're talking about horizontal, like vertical what distance or vertical motion here, the S change to what H, because we are not talking about what the height. We are not talking about what the height, right? So please pay close attention here. I have to what give you, I have to what make that I have to what show you that here. Hope you understand. So these are what equations of motion under what the influence of gravity, under what free fall. Just under what free fall is falling under the what influence of gravity. Just but when it's straight up, is what is acting against gravity. So whenever an object is being thrown up here, you see same thing here. This positive change to what negative. So the difference between the body falling under free motion, free fall, or acting here is what is the sign. When it's falling under the influence of gravity, it's positive. But when it's being thrown up, is what is negative. Just these are things you need to know. An orange drop to the ground, right? From the top of a tree. So the height is what? The height is 45 meter, right? How long? They're talking about what the time. The time. How long does it take to reach the ground? Right? Now, whenever it falls, now look at something here. There must be an initial velocity. Idea. And that initial velocity is 0 because it's falls from the height. So there is an initial velocity here. So my initial velocity here is what? 0 meter per second. So which one are we going to use here? We're talking about the time. So now what you can easily use here is going to be this one here. This one you can easily use, right? Because I know my height, my initial velocity is 0. I can really calculate what my t, right? Now, another thing I want to understand here is that G is equal to what 9.8 meter per second square. Just and that is what my G. 9.8 meter per second square or what 10 meter per second square, depending on the one you are using here. So we are using what this one, we are using this one here. So let me put our values here. Remember the other one will be 0 because here is 0. So you're going to be H equals to the other option is going to be 0. So it will be GT square over what 2. Just that. Now do you know the reason why it's like this? Because the other option is 0. Because the initial velocity is 0. Hope you understand. So now let's make T the subject of formula here. I should make T my subject of formula here. Here we have what GT square equals to what 2 what H, right? Divide both side by what G. Here we have what G. This is that. So what I have here is what T square equals to what 2H over what G. Now I'll tell you what the square root of both sides to remove this square here. Right? So if I should take the square root of here, let's say what am I going to get? I'm going to get T equals to what? Square 2H over what G. So this formula I'm going to use here. So I want to use T equals to what? Square root 2H over what G. So now let's input our values here. C equals to square root. Here we have 2 times my H is what is 45 over what 9.8, right? So what will not be the answer here? 2 times 45 divided by 9.8 square root. So going to be what? 3. So it's 3 what seconds? 3 what seconds? That is the answer here. Just and that is what the answer. That was question what? 3. So look at our question 4. So let's look at our question. Let's look at our question 4. A speedboat travel at an average speed of 20 meters per second. Calculate the distance it cover in what? 20 minutes, right? A speedboat travel at an average speed, right? At an average speed of what? 20 meters per second. What is the distance? Now, what is speed? Speed because of distance over what? Time. Just like your speed. Now they say that my speed, my average speed, yes, speed is what? What is my speed? My speed is 20 meter per second here, right? Now what is my time? My time is what? My t, which is what? T, which is what? 25 watts meter. 25 watt minutes, right? Remember, here we have 20 meter per second. So seconds here, time is already seconds here. So I will convert this one to what? Seconds. Just now, how do I convert to seconds? How do I convert minutes to seconds here? By multiply by what? 60, right? So going to be 25 times what? 60. Here we have what? 1500 what seconds, right? So now they are asking to calculate what distance. So if I should make a distance, it's a formula here, which is d equals to what? Speed times what? Time. Is okay. So my distance equals to what? My speed is what? Is 20 what? Minutes per second times what? 1500 what seconds, right? So here we are 20 times 1500. Here we have what? 30,000 watts. 30,000 watts meter. That is the what answer. So now I don't want to go further more because I don't want this video to be too lengthy, but more this kind of video will come your way. So if you're not subscribed to the channel, please kindly subscribe to the channel here. If this video is helpful, please leave a comment section that this video is helpful. Right now, which topic is giving you headache? As a student, which topic is giving you headache? Math, chemistry, and physics. Please leave it at the comment section. From the comment section, I might pick out my next video. Now, if you want to join our private online class, so I want to cover the 15 most start topic in 10 days. Join private online class. The class is what? 4,950. 4,950. I need to cover what the 15 most start topic in 10 days, right? Now, send me a DM on WhatsApp and be added to the group chat so I can join others who have made payments. Thanks for watching. See you in my next video.